So let's start. We were discussing coordinate plane, and after that relations and functions, and we have studied that function we can represent like this, like y equal to f of x. Okay, and here the f represent a function, and the x is input to the function and the y is the output. So we can say like the x is the domain and y is the range, or x is the input, y is the output. Okay, and we can write like this, that for example, number of days in a month. So if there is a function which is calculating the number of days in a month, then it will be like this: f of month, any function of months, and then it will return us number of days. So the month will be input, the number of days will be output. Okay, we can represent functions in a tabular way also. Okay, for example, the any function, so the in a table, the first row will be the input, the output, the second row will be the output. So from here we can this is just another way of representing functions, because we will study later on in detail. We can represent actually function in several ways, like in the term in the form of mathematical formula like this, w equal to f of d, and in a tabular function, no sorry, in a tabular way, and in a graphical way, so and so on. So this is another way. Okay, like this, you see, these are all a tabular way of functions. We can calculate also that which one is function, which is not, but at the same time it is in one way of representing functions. Okay, so today our most focus will be evaluating functions. Evaluating functions means that calculate. We will calculate the final value of the function. So to evaluate a function, evaluating a function means that find out the final output. Okay, and actually the final output is a range, if you remember. So meaning to say, input will be given for some function, and the output we will have to find out. This is called evaluating functions. So for example, if we have a function like this, okay, that f of x is a function, but this f of x is equal to this. The value is given x square plus 3x minus 4. So this is the representation of the function. But here one thing is unknown. What is that? Unknown. Yeah. X. Very good. The x is unknown. So we cannot find out the value of this function unless we know the value of the unknown, which is the x. So what should be the x value that we put here and find out the final solution? So these are just for exercise purpose. One time the x value will be 2, again next time the x value will be a, and next time the x value will be a plus h, and next time the a value will be f of h minus f of a over h. So this one is a bit complex one, but you see we are starting from simpler and going to little bit complex one to understand. Okay, so to evaluate this function using the value of x equal to 2, so how we can do that? You see, just as simple like that if I replace the x everywhere, the value of x, you see, everywhere the value of x by 2. So f of 2 equal to 2 square, like x square will become 2 square, and plus 3x will become 3 multiplied by 2. And here is no x, so no need to put. And you see, is like this. So 2 square will be equal to 4, right? And 3 multiplied 2 will be equal to 6. And then minus 4 is in the same way. So 4 plus 6 equal to 10, and minus 4, 10 minus 4 equal to 6. Or you can say like this also, that negative 4 and positive 4, this will be cancel each other, and plus 6 is the output. Let's continue. And the next one will be like this, that you see, now we will put the value of x equal to a. So we will replace every time x by a. Okay, this should be lowercase a, not uppercase a. Okay, so you see f of a equal to a square plus 3a minus 4. So we cannot further solve this because the input is given as a variable, as a is not a constant value that we could finalize and simplify until the last value. Okay, so we cannot further simplify. The answer will be the same, a square plus 3a minus 4. So according to the formula, if we replace the x by a and the y by h, then it will be equal to a square plus h square, okay, and plus 2ah. So the 2ah comes like this. So this is according to the formula. Actually, we directly apply the formula, and this according to the calculus book, or at this level, we or maybe the author assume that you already know that formula. But that's good. Thank you that you reminded me, and it was a good question, and hopefully now is clear. Is it clear now or not? Okay, so using this example, actually we can prove the formula also, that x plus y whole square is equal to x square plus y square plus 2xy. So the same we can prove from this one. You see how? Think like the 2 is x and the 3 is y. Okay, just assume. So it will become 2 square plus 3 square, okay, plus 2 times 2 multiply xy, like here 2xy. Okay, so the xy is again like x multiply y. So this will be, the x is 2 multiply and the y is 3. Okay, now 2 square, you tell me first. 4. 3 square, 9, plus, you see, 2 multiply 3, this one first. 2 multiply 3, 6, and then this one, yeah, 2 multiply is 3, 6, and 6 multiply 2 is 12. Okay, and now we have 4 plus 9 plus 12. You see, 4 plus 9 is 13, and plus 12. Okay, oh sorry, plus 12. Let me do like this. Okay, so 5 and 2, okay, 25. Okay, another easy way, a quick solution. If we have numbers, not variables like x and y, so you see, we can prove that yes, this formula is true. This is the correct solution of this formula. You see, if we do like this, that 2 plus 3 is what? 5. Okay, and then we can write this one actually like, sorry, like this one is like 5 square. Okay, and 5 square is what? 5 square? 25. So you see, according to this way also the solution is 25, and according to the formula way also the solution is 25. So we can say that anywhere from now onward, please everybody remember, you see, I wrote in this way, but actually in the solution is written like this, that first variable square plus the 2 multiply first and second, and then the last variable square is written later. I think this way is a bit easier to remember the formula, that first square, then the second square, plus 2 multiply first and second. Or maybe it is easy for me, I don't know which style is easy for you. You write for yourself and remember h minus f of a over h. So this will be the input this time. So if this is the input, then we can do like this, that you see, f of a plus h and f of a o divided by h. So if you remember, we just calculated f of a plus h. Okay, if you go one step behind in the slide, Okay, you see here we just calculated this one, f of a plus h. Okay, and you see this is f of a plus h. So the answer for a plus f of a plus h is this one. So we will just pick up this answer and we'll put at this place. You see, f of a plus h. So we already have the answer. And in the same way, here we have f of a. So f of a equal to a square plus 3a minus 4, right? So we have f of a plus h also, and we have f of a also. So just put the two answer, f of a plus h minus f of a plus, no, sorry, divided by h. So we will just put those solutions here. So you see the f of a plus h is the answer that we solved at the previous slide. Okay. Similarly, f of a is equal to a square plus 3a minus 4. We solved in the previous slide. Okay. So now combine both. Okay. Combine both in this style like this. Okay. So when we combine both, all of them, then we can write like this, that f of a plus h minus f of a divided by h, this is equal to the first component. You see this component, just put this component here until this, you see, and then this minus, okay, and minus, and then the second component, which is a square plus 3a minus 4, a square. But you see, in mathematics, remember that this minus will be in a bracket. Okay, don't make this mistake. Okay, so this minus, then bracket, then a square plus 3a minus 4. Okay, what is the role of this minus this minus, that actually this minus will multiply to the a, so the a will become minus a. Okay, and this minus multiply plus is again minus, and it is 3a. Okay, I hope you still remember that minus multiply plus plus equal to minus, and plus multiply plus equal to plus. Okay, and minus multiply minus equal to minus.
Plus.
Yeah, plus. Yeah, minus multiply minus equal to plus. I remember our teacher was telling you that like minus means no, and again minus means no, so 2 times no, no means yes. Okay, something like that. So negative a square, okay, and then negative 3a, and you see this minus multiply minus will be equal to plus, so this will become plus 4. Okay, so if we have plus 4, so this plus 4 will cancel with this minus 4. Is it okay? And this negative minus 3a will cancel with this positive 3a. Is it okay?
Okay, sir.
And this, you see, this negative a square will cancel with this positive a square. So finally what left? 2ah left, and h square left, and 3h left. And you see 2ah plus h square plus 3h divided by this h. And then if you see in these two terms, h is, no, in all three terms, h is common. So when there is any variable common among different different components, then we can take the common outside the bracket. So you see this h will go outside the bracket, so it will become 2a, and here h square means that here are two h. Okay, so one h will go outside here, and the one h will left, and here is only one h, it will go outside, and only 3 will left. Okay, so in this case we have and if let's suppose further we divide or we simplify, then this h will cancel with this h, and what left? 2a plus h plus 3. Is it clear?
Yes.
So if it is like this, that x minus y whole square, then it will be equal to x square plus y square, not the point, plus, okay, plus y square, but negative 2xy. Okay, so this will be, next time if there is any calculation, we can directly put like this. Okay, and you can actually prove this formula if you replace the x and y by some number and do like last time we did 3 plus 5. So here you can do some other you can put any values that you want and then apply, and you will get the final answer. So these two, yeah, the two formulas, x plus y whole square and x minus y whole square, please remember. And this, if anyone is confused in this, that minus multiply x, sorry, minus multiply plus is actually equal to minus, and plus multiply plus equal to plus. Okay, and minus multiply minus equal to plus. So these type of these are the basic things. Actually, I told you at the beginning that I will try to teach you in such a way that from very beginners level. So anyone who didn't study these concepts in previous classes, don't worry, I am trying my best to teach you now. So remember this point and remember the two formulas, and hopefully should not be a problem. And then let's go ahead. Okay, so next level. Yeah, so it is like this. So you want to try this one now. So you see, we need to find f of p. You see, we can use f of p also. Okay, f of p, and the same f we can actually represent by any other alphabets like h of p. Okay, h of p, g of p. So don't confuse with this, right? Okay, any character here, it represent a function. Okay, so h of p equal to p square plus 2p, and now replace the p. You see, you will only replace the input, and the input is in the bracket 1, inside the bracket. Okay, so replace the p by 4, okay, by 4, and now put here and find out the solution. So I am waiting for you. What will be the solution? Competition, who will tell me first? Yeah, the function symbol sometime maybe g, okay, g like this, and the input symbol may change by p by m. So g of m is a function, and it is equal to m minus 4 square root. Okay, square root of m minus 4. Okay, note the point, the square root is on the whole m minus 4. So if we replace the m by 5, what should be the answer?
One. Only one.
Only one.
Yes.
One, sir, one.
One. Okay, very good. Okay, good. Then I think we are in a right way. We are learning. Okay, next one. H of p is equal to p square plus 2p. Okay, and solve for h of p equal to 3. So meaning to say, we will replace each p by 3. P square plus 2p equal to 3. Okay, so according to this, you see, the h of p equal to 3, meaning to say the left hand side of this equation is equal to 3, and the right hand side is p square plus 2p. Okay, so mostly when we are solving this type of question, we transfer or we push the 3 to the left hand side. And note the point, when you bring any variable or any constant from one side of the equation to another side of the equation, then its symbol change. For example, if you bring plus 3 from the right hand side to the left hand side, it will become minus 3. And if you bring minus 3 or minus x or anything to the other side of the equal sign, then its symbol will change. It will become plus x, and vice versa. If it go from here to there, still the same rule apply. So you see, negative 3 if go here will become positive 3, and positive x if go here then will become negative x. So in this way, this positive 3 when change to the left hand side of the equal sign, then it become negative 3. Now we have p square plus 2p minus 3 square. Okay, here is little bit one hidden step, that why it become p plus 3 and p minus 1 equal to 3. Why this change to this one? Okay, so actually there is another one formula which is called factor formula, and the factor formula is like this, that if you have any let me remove this one now, that if you have any equation like this, like any variable square, like here p square, and then 2 multiply the variable, so 2p, okay, and another one minus 3. If you have any equation like this, then to further solve, then the point is that identify, point out, you see I have given here, point out a, b and c in this equation. So if we say that the p, let replace the p by a, meaning to say p equal to a, okay, then what will be b? Only 2 left and 3 left, because the p equal to a. So let's suppose the 2 equal to b and the 3 equal to c. Okay, so we identified a, b and c in this equation. Okay, now to further simplify, then you do what? Then you see, find out, then find two such numbers, that when you multiply together you will get the c. Okay, and when you add it together, meaning to say when you plus together, then you will get p, sorry, b. Yeah, I'm repeating again. So find out two such numbers that when you multiply, okay, then you will get negative 3, and when you plus together, then you will get plus 2. So these number only plus 3 and negative 1, okay, negative 1. If you plus together, okay, let's plus together. So plus together means, you see, this is plus 3 and this is negative 3. So any time when there are two number, one positive, one negative, and you are plussing together, actually the actual operation will be minus, because of this minus. So 3 minus 1 equal to 2. Okay, so it will be positive 2 or negative 2, because here is positive also and negative also. So this, the rule is that the symbol will be of the bigger number. So here 3 is bigger, so it will become positive 2. So meaning to say, you see, when we plus these two number, we got plus 2. And if the same we apply multiplication now, okay, so we know that, you see, plus multiplied by minus is equal to minus, and 1 multiplied 3 equal to 3. So you see, when we multiply, we get minus 3 is this one. And when we added these two numbers to each other, then become 2, which is this one, plus 2. So in this way, these two numbers will, according to the factorization rule, it will become, we can change this step to this step. You see, the two number, the 3 and 1, so p plus 1 or p plus 3 into p minus 1, meaning to say the p plus the first number, the you can say like p plus a, and multiplied by p minus b. Okay, like this. Okay, now we can represent functions through a graph also. Okay, so verify a function by graph, meaning to say, if we have any function uh, and we solve that function, then we will find the input of the function and we will know the output of the function. So if we have input and output, we can actually represent that function in a tabular way also, like this. You see, the first one will be input, this one will be the output. So according to this table, it means that this is such a function that when we give negative 3 as a input, it will change to positive 3. And when we give negative 2, it will become 0. And when we give 0, it will become 0. And when we give 1, it will become 3. Okay, and if we give 4 as an input, it will give 24 as a output. Until this point, clear?
Yes, just substitute the P, right? In
Yeah,
the
just
equation.
yes, 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 exactly. But you see this h of, yeah, like this, you see this is the function h of p equal to p square plus 2p. Okay, according to the previous one we have already solved this. Okay, so now to represent this function in a graph, it will be like this. You see this graph actually represent exactly the same values. Like when it is 0, okay, then it is 0, and when it is negative 2, you see at negative 2 it is again 0. Okay, and at negative 3, here, if negative 3 is the input, output is this one, output is positive 3, right?
Yes, sir.
Okay, good. And if the input is 1, you see here, then output is again 3. So two inputs, you see, two inputs. At 3, the output is 3, and at 1, the output is 3. Okay, and at 4, you see, if you go here, if the input is 4, the output is 24. Little bit down, then 25 means 24. Okay, so this type of functions we can represent through the graph also. Okay, so we will do like this. You see now, if we put, like, you see, at negative 3 also 3, and plus 1 also is 3, and if we put this one, the whole equation equal to 0, then it will be like this: p plus 3 into p minus 1, okay, equal to 0. Because you know that the equation was like this, that p plus 1, and if you go one step back, you see, p plus 1, sorry, p plus 3 into p minus 1 equal to 3, right? Keep in mind this step: p plus 3 into p minus 1 equal to 0. So if we put this one, p plus 3 into p minus 1 equal to 0. So if the whole equation, the whole left hand side is equal to 0, so it means maybe this component is 0, so 0 multiplied p minus 1 will be 0, or this component is 0, then p minus 1 is 0, so 0 multiply p plus 3 will be 0, because anything multiplied by 0 is equal to 0. Okay, or maybe both of them are 0. Okay, so if this is the situation, when we assume like this, then we can say that p plus 3, either p plus 3 equal to 0. Okay, so if we assume this one equal to 0, then actually the p will be equal to negative 3, because you see negative 3, yeah, the p will be equal to negative 3. And if we assume that p minus 1 equal to 0, okay, here at this point, you see, if we assume that this one is equal to 0, then the p will be equal to 1. Okay, the p will be equal to 1. So we get two possible values for same input. The p is same input, right? But two possible value, one negative 3 and one positive 1. Okay, so in such a case, we will have to do the output of h of p is equal to 3 when the output is either 1 or either negative 3. Okay, so you see, negative 3 is also equal to 3, and 1 is also equal to 3. Okay, so the graph verifies, you see, the same thing, the same concept, the table and the graph actually show the same thing, that if p equal to 1, okay, p equal to 1, then the output will be equal to 3, or if p equal to negative 3, the output will be 3. And the graph also shows negative 3, the output is 3, 1, the output is 3. Okay, so in this way, when we solve a function, we can represent that in a tabular form also and in a graph also. Now there are some functions uh, and their graphs that we can actually represent like this. So some functions are having specific names. like constant function, meaning to say constant functions are such a functions that whatever input you give, okay, whatever input you give, its output is yeah, its output is always the same. Okay, this is why it is called constant function. Okay, and it is written like this, that f of x equal to c stands for constant. Okay, so meaning, you see, we can represent that function like this, that whatever value you give, it will be constant. Like if the value is 1, it is still the 2. Okay, if the value become 2, it is still 2. It is 4, and the output value is still 2. Or maybe if it is -1, you see, the output value is still the same 2. Okay, -4, -3, any value you give, its value is output, and the same is represented by the function under the table, that any input output is the same. Such function is called constant function. And there is another function, its name is identity function. So any function which give us the output exactly like the input, meaning to say it actually doesn't change the input to anything else. So the same input become output. It is called identity function. Like you see, this one, -2 is the same -2, 0 is the same 0, 2 is the same 2, 3 will be 3, 4 will be 5. So, and its output will be like this, like 0 will be 0, 1 will be 1, 2 will be 2, okay, 3 will be 3, and 4 will be 4. Negative will be, so the straight line will be its graph. Okay, this type of a straight line going through the origin uh, will be its graph. Okay, and this function is called identity functions. Absolute value or absolute function, it means that if you remember, absolute function or absolute value is such a value that if the input is plus or if the input is minus, the output will always be plus. Okay, but the same value will not change, only the symbol will change if the input is negative. Like in this case, you see, if -2, the output will be +2. If 0 is the same 0, if 2 is the same 2. Okay, so the value doesn't change, only the symbol change. These type of functions are called absolute functions. And quadratic functions are like this, that the f of x will be equal to x square. Okay, f of x will be equal to, the output will be equal to x square. This is not x2 actually, x square. Okay, the table clarify this, that if -2 is the input, so it's x square, the function will become 4. So -2 multiply -2, so negative plus, and 2 plus 2 is 4. Okay, and similarly -1, the output is 1, so square of 1 is still 1. 0 0 1 1 1, and +2 plus 4. Okay, so this is a quadratic function, and quadratic function, if you put these values, you see, for 0 it is 0, for 1 is 1, for 2 is 4, and for 4 it will be 16, quite somewhere up like this. Okay, and the same goes for the negative value, so its graph will be something like this. Okay, so this is called quadratic function. And then cubic function, that any input, the output is its cube. Cube is any value raised to the power of 3. Okay, so cubic function f of x equal to x cube, and it is like this. So -1 multiplied 3 times, okay, is the same -1. Okay, negative 0.5 multiplied 3 times with each other, so its value will be like this. Okay, 0 is the same, and 0.5 multiplied 3 times, okay, will be 0.125. Okay, and 1 will be the same, and then its graph will be like this. So this is called cubic function. A reciprocal function is the out the any input, such a function that any input to that function will be equal to 1 divided by that input. Okay, like you see, x then it will be 1 over x. Okay, if let's suppose the x is 2, the output will be 1 over 2. If the x is 5, the output will be 1 over 5. Okay, and it is like this. Negative 2, 1 divided by negative 2, its value will be 1 over negative 0.5. Okay, and 1 is the same thing, because 1 divided by 1 is the same thing. Negative, it will be the same. Okay, so 1 over anything, anything the same value, then will be meaning to say 1 divided by the input. F of x equal to 1 over x, and its graph will be like this. And reciprocal squared, so it is just 1 over x square. Okay, any input, output will be 1 divided by the square of that input. Okay, and it will be like this. You see, 1, let's suppose 0, it will be 0, 1 will be 0, no problem. But 4, okay, if 4 is the input, then it will become 1 over 4 square, for yeah, x square, yeah. So here, if it is 4, then 1 over 4 square will be 16, and 1 over 4 square 16. Why it become like this? Wait. F of x, and then the third root of the input. So one is square root. The square root value is 1 over 2. Okay, that is called square root. And third root value is 1 over 3. Okay, so any input like x, y, then output will be the input, the third root of that input. Okay, and we can do these things through calculations, through calculators. Yeah, just some well-known functions that maybe we can see somewhere, and we will whenever if we see, we can use it, and its common graphs looks like this. Okay, so next one. Okay, combining functions. Combining functions means that we combine one function with another, or we put one function inside another function. Okay, for example, if we say that we want to calculate how much it cost, you see how much it cost, this is one thing, to the heat of a house, this is another thing, of a particular day. So you see, this is the heat temperature of the day, this is one function, and then this temperature of the day is input to the cost function. We can simply say, like, you see the output, this t of d is a function. So this function will have some value, but whatever value this function has, the output of this function become input to the other function. So in this way, we can actually combine even 1, 2, or 3 levels of function. Like you see this c of, you see, so here will be input to this function. But if we put as an input another complete function, okay, like f of x something, so you see, now first this f of x will be solved, and the f of x will give us some output, and that output will become input for the c function, c of that. Okay, so this is called combination of functions. Remember in a mathematics that if we have like brackets 2 into uh, let's suppose like this, 2 into 3 multiply 4, okay, multiply 4, and then let's suppose minus 2, and here a bracket. So you see, this is the outer bracket, and this one is the inner bracket. So whatever the result of this inner bracket, we will solve this one first, and the result will come as a input to the outer brackets. So you see, this will be like 3 times 4, 12. 12 times 2 is 24, and 24 minus 2 is 22. Okay, so you see, this will be the input for the outer one. In the same way, here we have two input or two functions combination. So the inner function will be solved first, and whatever is the output of this inner one, it will become input to the outer function. Okay, it will be hopefully clear by the coming examples. Let's see. Okay, that if we want to find out the husband and wife separate annual income over a period of years, you see there are two functions, husband and wife. So the income of each one, so income of each one are calculating income of each one is a separate function, and after that combine both together to find out the total income. Okay, so the total yearly income is totally yearly income equal to the husband yearly income plus the wife yearly income. So we can write like this. Okay, the T of H will be equal to H, which is a function of the husband yearly, meaning to say what is the output of this function plus the output of this function. Okay, so in the same way, you see, we actually like here the word is the total income. So when is a totaling is plusing. In the same way, you see, if it is, we can write like this. You see, the two functions we can actually we can plus to each other. Okay, and in the same way we can minus two functions from each other. Okay, like f of x minus g of x. Okay, and in the same way, we can multiply two functions, f of x multiplied by g of x, okay? Or divide two functions, f of x divided by two functions. So meaning to say, functions can be added together, functions can be subtracted from each other, and can be multiplied and can be divided by each other. So we assume like the functions are like normal constant value are variables, because the final output of a function is some final value. So we can add values to that output value, or we can subtract, or we can divide, or we can multiply. Is it make sense? Okay, so next level, find and simplify functions. You see, this one is g minus f of x, meaning to say g of x minus f of x, and the other one, g over f of x, meaning to say g of x divided by f of x. And given that f of x, you see, we have f of x also and we have g of x also, two functions, one time minus from each other, another time divided by each other, but the f of x is equal to x minus 1. Okay, and g of x is equal to x square minus 1. Okay, x square minus 1. So if we do like this, the minus first. Okay, so g of x minus f of x. So you go to g of x. G of x is where? G of x is this one, x square minus 1. You see, this is g of x square minus 1, and f of x is x minus 1. But note the point, you see, that this is a separate external minus. Okay, sometime this is tricky, don't forget. So when there is a minus, then you will put this one, this component in a bracket, because this minus will actually multiply here. Okay, so final will be what? That x square minus 1, and this will become minus x, and minus multiply minus, it will become plus 1. So plus 1, I should do one level here. So actually it will become minus x, okay, and plus 1. Okay, so the plus 1 will finish with the minus 1, and the plus x will, no, there is no other x, so it will become x square minus x. So both have one common, then it will become x into x minus 1. Okay, so then the same goes for division, that g of x divided by f of x. We know that g of x is x square minus 1. So we put the g of x value, and f of x value we have x minus 1. So put this one. Now, you see, this one we can write, actually there is another one formula. You see, here is this one come again. In a previous slides, we learned two formulas, if you remember. X plus y whole square. Okay, this was included in a metric mathematics, and x minus y whole square. Okay, and there is another one. You see this, that you can say like this, that x plus 1, okay, into x minus 1, this is actually equal to x square minus y square, but here is the y is 1, so even 1 square is again the same 1. So x square minus 1, we can apply the formula that it will be equal to x plus 1 into x minus 1. Otherwise, if you multiply this together manually, it will give you again the same value. Okay, so x plus 1 into x minus 1 divided by x minus 1. Okay, so you see the x minus 1 and x minus 1 cancel with each other, and the value left x plus 1. Okay, good. So let's continue. What about this one? F g of x, meaning to say f of x multiplied by g of x. Okay, and f of x minus g of x. Okay, so okay, I think I have given this one to you guys that you try. So again, you quickly try. You see, we have the value of g of x, right? And we have the value of f of x. Okay, so what about if we multiply f of x multiplied g of x, and if we minus f of x minus g of x? Can you try? Okay, let's continue. Let's go together. And can anyone help me? What is the value of g of x? Uh, okay, value of g of x is g of x equal to x square minus 1. Okay, and the other one is, I think, x minus 1, right? Okay, so x square minus 1, this will be g of x. Okay, in case of multiplication, the order doesn't mean, like for example 2 multiply 1, okay, is equal to 1 multiply 2. Okay, the order doesn't matter in case of multiplication. So you can write g of x multiplied f of x, or f of x multiplied g of x, so no problem. And f of x is x minus 1. The values are correct.
Yes, yes.
Okay, so if correct, then we can do like this, that we can actually multiply manually also. Okay, so how to multiply manually? Meaning to say, we will multiply the x square to each component first. Okay, like x square time x will be equal to
X cube
x cube. Very good. And x square time minus 1
minus x square
minus x square. Very good. And minus 1 time x
minus x
minus
square.
x.
What?
Yeah,
Yes.
yeah, minus, this time we are multiplying the minus with this two factor. Okay, so
Okay, sir.
minus 1 time x is minus x, and minus 1 time minus 1 equal to
Plus 1.
plus 1. Okay, very good. Now x, if we take a common x out, so this will become x square, and this will become x,
Onyx.
and this will become minus 1. Okay, and plus 1 will be outside because it doesn't have common factor.
Oh, okay,
Yeah,
sir.
yeah. So is it clear? Oh, good. Yeah. Who is confused? Let's apply the same values in the other function, like opposite of that. G of x is the external function now, and f of x is the internal function now. Okay, so you see, we know the value of f of x. F of x is x square. Okay, so meaning to say, g of x will become g of x square. So the x square is f of x. Okay, and now you see, this one is g of x. So the input plus x plus 2. Okay, so the input is x square and plus 2. It is so simple. Okay, now if you see, you see the output of this is not equal to the output of the other one. So it means f of x, g of x is not equal to g of x of f of x. Okay, so it is not equal when you change the order of the inner function and the outer function. I hope is okay, clear. Go next. yeah, we can apply these functions, the composite functions we can apply like this, because we have the values of the functions. And if you have a value of function, like you see g of x, okay, so g of x is 1, okay, um, g of x, and when g of x is 1, here, oh sorry, yeah, when g of x is equal to 1, let me take this, then it is equal to almost 3, right? I think almost 3.
Yes.
Okay, so meaning to say that the output, the g of 1 will return 3, and it will become f of 3, right? It will return f of 3, and we know f of 3 is what? If f of 3 is this one, so it is 6. So the final output is 6. Is it make sense? Is clear? I'm trying my best. Okay, so next one. Oh, the answer is like this, that g of x, g of 1, you see the output is 3, and when output is 3, then and when input is 3 to f of x, the output is 6. We can show like this. Okay, so now evaluating the inside function using the input value or variable provided, using the resulting output. Yeah, how to evaluate? The procedure is like this, that you will evaluate the inside function first using the input value, and the output of the inner function will become, you see, the resulting output as the input to the outside function. Okay, so example given, if we apply furthermore f of t equal to t square minus t, and h of x is equal to 3x plus 2. Okay, now evaluate f of h of 1. Okay, f of h of 1. So h of 1, you see, put here is 1, so here will be 1, so 3 times 1, okay, f of 1, so 3 times 1 plus 2, so 3 times 1 is 3, and plus 2 equal to 5. Okay, now if we evaluate, okay, so you see the 5 is the output of this, you see, h of 1 means 5, so the output of h of 1 uh, will become input to f of x. So you see the x will now replace by 5, and we know that that is equal to t square minus t. Okay, so the t is actually the 5, each t replaced by 5. Okay, so t square means 5 square minus t is the 5. Okay, so 5 square is 25, and minus 5 equal to 20. Okay, so I think it's quite simple. Oh, yeah, the same thing, right? I have already did. No, this is, I think, another question. It is this. Wait. 3x plus 2. Yeah, it is the same thing. No, it's not the same thing. Last
Yeah,
time,
yes, sir.
yeah, last time we solved for you see, this is another variations just for practice purpose. Okay, that h of f of 2, f of 2. So we know f of t, so replace each t by 2. Okay, each t by 2. Do you want to try?
Yes, sir.
Okay, uh, then I should create a link, and maybe you upload to the same one. That okay, I will create a quick link. F of 2, so 2 square minus 2, and this will become 2, and now 3 of 2 plus 2 is 8. Yeah, okay, this is correct. The first one is correct, but the second one is wrong. You see why it is?
Sorry, sir.
you get where is your mistake?
Uh, -6, right?
Yeah.
Ah, I see.
Yeah, so it will be, and you see this negative is actually no, because f of 2 is negative 2. So negative 2 square, you see, like t square, you see, the f of is t square minus 2, right? Minus t, right? Okay, so minus 2 square minus 2. Okay, so minus 2 square, actually square is again positive value. Okay,
So it's positive 4.
huh? What I did? What?
No, you were right, sir.
Okay, so in this case, it should be the 3 should be multiplied with 6. So 3 times 6 is 18. Okay, and then plus 2, 18 plus 2, the answer should be 20. You get or not? Are you still confused?
Yes, sir. I'm following you.
Okay, let me check any other one. Yeah, Nuraz Mira, you are right. 8 and 20. Wow. Okay, good. Okay, so you see here, h of f of 2. So we know f of 2 is t square, okay, t square minus t. Okay, so means replace each t by 2. So 2 square, okay, 2 square minus 2. 2 square is 4 and minus 2 equal to 2. Now you see this 2 will become input to the h, meaning to say we will find f of, no sorry, h of 2. Okay, and we know that the function h of x or h of 2 is equal to 3x times 2. Okay, this is equal to 3x plus 2. Okay, replace the x by 2. So 3 times 2 plus 2. Am I right? Yeah, 3 times
Yes.
3 times 2. Oh, this one is wrong. 3 times 2. 3 times 2. Sorry. So this will be 6 and plus 2. And this will become 8. So this is correct. Now, let's come to the next one. The next one is a bit tricky. H of f of negative 2. So it means we will replace this t by negative 2. So negative 2 square, okay, negative 2 square minus negative 2, right? It will be like this. Don't confuse this minus with this minus. Sorry, excuse me. So this one will become, the square of negative number is again positive number. So negative 2 square is 4, but this negative time negative is equal to plus. So 4 plus 2 equal to 6. So this time we will find, you see the f of 2, the f of 2, f of minus 2 give 6. So we will find h of 6. Okay, so meaning to say here, we will replace the x by 6. So 3 times 6 plus 2. 3 times 6 is 18 and plus 2. Okay, and that will be equal to 20. Okay, so it works like this. Is there, hello? Okay.
Yes, sir.
So finding domain means input, range means output. So finding the domain of a composite function, meaning to say that there one function will be inside another function. So you see here we have f of g of x. So first of all, think about the g of x. So the input to g is x, and the input to the uh, h, input to the f, is the whole g of x, is a function. We can say like input to the g is a variable x, but input to the f is not a variable, is a function. Okay, so in this way, if we want to find domain of a composite function, then first of all we will find the domain of g, and we know the domain of g is x. Okay, domain of g is x, and after that, once you have you put the, if you have any value for this x, then you will put that value in the x, replace the x by that value, and you will finally got some value, like previously we got 8 and 20. Okay, so you will get the domain of the input first, and then you will calculate, and then you will get the input of the output, the external function. Okay, then find those inputs, okay, x in the domain of g, meaning to say first find the domain of g, which is g of x. Okay, so meaning to say, you see, if we have a function g of x, the domain is what? Domain is, the domain is x. Okay, if we have g of x, the domain is x. Okay, and then the g of x as a function will be domain of f. Okay, and if there is any such put, any such anything, any such value, exclude those inputs like x from the domain of g for which g of x is not the domain of f. Meaning to say, the f of f is a function, it will have some, okay, it will have some input, but if the g returns such a value which is not in the domain of f, then remove that value from g of x. It means that g of x has, if we have a function g of x like this, okay, then it means that this function has domain also. It will have some values. Okay, I'm just putting like 1 2 3, let's suppose. Okay, it will have domain also, and this will have range also. Let's suppose if it is 4 and 6. Okay, so now this g of x is a function which has a domain also, and it has a range also. Okay, now this whole function is input, this whole function is input to another function. Okay, like this. Now this will also have the f of function, like g of x has domain and range, f of x will also have domain and range. Let's suppose this is domain of this, and it will have some range also. Until this point is clear, every one of you?
Yes, sir.
Yes, sir.
Okay, now you see, if the g of x, okay, now we know that due to input value, this input value, the function generates output, right? And this output of this function will become input, means domain for the outer function. Okay, okay, so if let's suppose here the values are 1 and 5 and 6, let's suppose. Now you see, the domain of f is 1 5 6, but we know that this domain comes from the range of this function, right? So here 4 should be included here, but is not included. So it means that this 2 generates the 4, and actually the 4 is not suitable here because it is not part of the domain of f. So what we will do, that we need to throw this value from the range of, from the domain of g, because it generates such a value which is not the domain of f. Is it clear or no? Maybe is a bit complicated, but the point is that our main target is that to find out the domain of the complete composite function. So the finding the domain of composite function means that we will find the domain of f, this one. Okay, so our target is this one actually, but this is actually the result of this one, and this result, this output depends on this input. You see, there are three levels of complexity. This input goes to this function, it gives this output, and this output goes as a input here. So if we know some time such value that actually it doesn't exist, let's suppose the 4, we know that it doesn't exist here. So, and this 4 is created by this 2, actually. So this 4 is not the member of domain of f. Then we will have to remove this value and put such a value which generate the 5. Okay, so in this way we can find the domain of a composite function, and whole this discussion is about that. Okay, now if we apply this concept on this composite function, that f of g of x, okay, and where the f of x is 5 over x minus 1 and the g of x is equal to 4 over 3x minus 2. Okay, 4 over 3x minus 2. Okay, so now if we put the value, if we replace this x by 2 over 3, okay, 2 over 3, then it will become like this: 4 over 3 multiplied by 2 over 3, okay, 2 over 3, and this minus 2 is its own. Now you see, 3 multiplied 2 divided by 3, so it means this 3 and this 3, let me remove this and change the color. Okay, this 3 and this 3 will cancel each other because 3 divided by 3 is 1, and after that we left plus 2 and minus 2. So plus 2 and minus 2 will cancel, it will become 0. So it shows that the overall denominator become 0. And we know that anything divided by 0 is infinity. Okay, we don't know the value actually. So you see, from g of x, from the domain of g, we will remove all those values which can create problem. So infinity we cannot handle. Okay, so this x should not be equal to 2 over 3, and this x should not be equal to 2. Okay, so if it is equal to 2, then 2 times 3 will be 6, and 6 minus 2 will be 4. 4 divided by 4 will be equal to 1. Yeah, okay, like this. And this one is yeah, 2. So if it is 2, and here we put this, okay, if it is 2, let's suppose 2, so 6 for, yeah, okay, so if it is 2, then we get the final output as 1, and the final output, if it goes to as a input to this one, then you see here we will replace the x by 1. So x by replaced by 1, and then again minus 1, so plus 1 minus 1 cancel each other, so here again it create 0, and 5 divided by 0 is equal to another infinity. Okay, so these two value, if the x in g of x is 2 or the x in g of x is 2 over 3, both these value create results into infinity. So we will remove these two value from the domain of g of x first, because the result of this create problem for the f of x, and in this way we can find out the domain of some function. I hope it is not too complicated. let me copy this.
Sir, so the domain is not actually the X, but we want to find the range, right?
Wait. Let me make it like this. Okay, now you say you want to say what?
That X, we actually not want to find the answer for X. We want to find like the range where the X should be, right?
No. Yeah, you are right, but we the same. I can say what you are trying to say in other words. In other words, here in this case, we are trying to find the domain. Okay, we are trying to find the domain. So to find this domain, actually we need to find the range of this, because the range of g of x, okay, the range, it has, let's suppose, domain, okay, and range, and we know that the range, the output of this function will become input to this, right? Until this point, clear?
Okay, clear, sir.
Okay, now you see, if if we if here is any such value, which create here, which generate here infinity, and then this infinity will go as an input, then the f cannot handle it, right?
Yep, sir.
So you see here, now this 4 over 3 of x, 4 over 3x minus 2, 3x minus 2, okay, if I uh, okay, let me change to easy example. Let me try easy one. Wait. Okay, if it is, let's suppose, like this, 2 over x minus 2, okay, 2 over x minus 2. Now if we put, let you see, if we put replace the x by 2, so 2 minus 2 is equal to 0, right? And 4 divided by 0,
Yes, sir.
4 divided by 0 is
Uh,
infinity,
Zero.
is
Yeah,
infinity.
infinity, I mean.
Okay, and this infinity will go as an input to this, right?
Yep, sir.
So infinity as an input is a problem. Is this f of x cannot find any value of infinity, because infinity is unknown, right?
Yep, sir.
Okay, so if this f of x cannot handle infinity, then we cannot find the domain of this, because the function cannot generate any value. Okay, so but the problem is here. So meaning to say, if here is 2, it will give us infinity, and this infinity goes here, okay, as an input to this place, okay, and this input will go into this, and it will generate some output as a range. But if this one is already infinity, it cannot generate anything. So the problem actually starts from this 2, right?
Yep, sir.
So meaning to say, the actual problem is the 2. Then the solution is to remove any problematic input from the domain of G, okay, which can cause problem to f of x. So simply remove the 2 and maybe put something, let's suppose 3. Okay, so if you put 3, so 3 minus 2 will be 1, and 4 divided by 1 is equal to 4. Okay, and 4 if go here as a input, so no problem, whatever is the result, it will be okay. Like 5 divided by 4 minus 1, so will be 3. 5 divided by 3, we will get some value, right? So at least we will get some,
I see, sir.
we will get some value. But if we put the 2, okay, it create infinity, and this infinity will be here, and if this infinity go there, the other function cannot handle it.
Now I get it, sir.
Oh,
Sorry for
it's
troubling
okay.
you,
It's
sir.
okay. It's okay. It's okay. I am happy that you learn it. If anyone else, anyone who didn't, so let's go ahead. This is the same discussion that I explained, okay, and the same values that I explained. And finally, thank you. If any question, most welcome.